Hello everyone, we will do one more problem in simplex method. Now before going to start the simplex method problem, we have to convert the given LPP into the standard form. How to convert into the standard form? I'll tell you. Now the standard form, how can you get? The given problem is in the maximization type. That's why no need to touch that one. Just we can write as it is. Max z is equal to 2x1 plus 4x2 plus x3 subject to the constraints. The first constraint is having less than or equal to symbol. That's why we have to add one slack variable called s1 on the LHS side of the constraint. Second constraint is also having less than or equal to symbol. That's why we have to add one more slack variable called s2. Third one is also having less than or equal to symbol. That's why we have to add one more slack variable called s3 on the LHS side of the constraints. We will write first constraint x1 plus 3x2 plus s1 is equal to 4. The second one 2x1 plus x2 plus s2 is equal to 3. Third one x2 plus 4x3 plus s3 is equal to 3. And all the variables, decision variables as well as slack variables greater than or equal to 0. Now like this we have to convert the given problem into the standard form. After converting the given problem into the standard form, we have to start the simplex table. Before going to start the simplex table, we have to draw the table first of all very much carefully. The first column is for CB. The next column is for basis B. The next column is for variable body of the simplex table. How many variables are there here? You observe very much carefully. x1, x2, x3, s1, s2, s3. 6 variables are there. x1, x2, x3, s1, s2, s3. After that constant, and the last one is the minimum ratio. Minimum ratio. But this is the last one. Now draw one more line like this. Now here CJ, we should write above the table the CJ. What we should write in CJ? I'll tell you. CJ, what we should write? Maximization Z contains coefficient of x1 is 2, coefficient of x2 is 4, coefficient of x3 is 1. We will write coefficient of x1, above x1 we have to write 2, coefficient of x2 4, coefficient of x3 1. Any coefficient of s1 here in the objective function? There is no s1, that's why 0. There is no s2, that's why 0. There is no s3, that's why 0. After that we have to draw the body of the simplex table. How to write the body of the simplex table? Using the first constraint, first row. Using the second constraint, second row. Using the third constraint, we will get third row. The first row is coefficient of x1 1, coefficient of x2 3. Is there any coefficient of x3? 0. S1 is 1. S2 there is no. S3 there is no. Constant is 4. Second one is coefficient of x1 is 2, coefficient of x2 is 1, no 0. Third one as well as s1 0, s3 0 and 3. Now the third constraint is x1 is 0, x2 is 1, x3 is 4, 0, 0, 1, 3. Draw one line like this. Now based on these variables, based on these three constraints, I draw the body of the simplex table like this. Now after writing the body of the simplex table, put one hand like this. Now if you observe, we have got the identity matrix in the end near s1, s2, s3. Near s1, s2, s3 we have got identity matrix because we have 3 rows. That's why 3 by 3 identity matrix we have got 1 0 0 0 1 0 0 0 1. The identity matrix we have got near s1, s2, s3. That's why s1, S2, S3 is a basis. Wherever identity matrix we will get, that elements are called basis. That elements are called basic variables or basis. Now above CB, coefficient of basic variables, above S1 0, above S2 0, above S3 0 is there in the objective function. That one we have to write 0 0 0 here. Above S1 0, above S2 0, above S3 0. That's why here 3 zeros. And draw one more line like this. This is the index row. What we have to do with the index row? Index row. What we have to calculate the index row using the formula Zj minus Cj. Using the formula Zj minus Cj, we have to calculate. This is the initial basic simplex table. That's why initial simplex table. That's why 0 into first element plus 0 into this one plus 0 into this one minus 2. How to calculate Zj minus Cj? Zj means CB column into first column minus a Cj element. Here CB column into second column minus a Cj element minus 4, like that. 0 into 1 plus 0 into 2 plus 0 into 0 minus 2. In the same way 0 into 3 plus 0 into 1 plus 0 into 1 minus 4. Like that we have to calculate. Because this is initial simplex table, that's why whatever the values are there here in the objective function, quite opposite values only you will get here. Why? Because here 3 zeros occurs. 0 into anything is 0. That's why. Now whatever the values are there, 2, 4, 1 are there. That's why minus 2, minus 4, minus 1, 0, 0, 0. Now quite opposite values only you will get. But this is the initial simplex table. From the next iteration onwards, we have to calculate this as Zj minus Cj very much carefully. Now here from here we have to start the simplex table. How to start the simplex table? The simplex table is you have to observe the index row very much carefully. In the index row, identify the most negative value or most minimum value from the index row. Index row, the most minimum value is minus 4. Put one arrow like this, and coming to the minimum ratio. Come to the minimum ratio. In the minimum ratio, we choose the minus 4 is the most minimum or most small most minimum value. Now that means we choose the second row, second column. We choose the second column, x2 column we choose. Now minimum ratio. Coming to the minimum ratio, 4 by 3. Constant is minimum ratio. How to calculate minimum ratio? This constant by this choosed column. 4 by 3. 4 by 3. After that 3 by 1. After that 3 by 1. 3 by 1 is 3. 3 by 1 is 3. 4 by 3 is equal to 1 point something you will get. 1.3 or something like that you will get. Now minimum ratio, if the minimum ratio column contains any negative or infinity, just ignore or omit it. Do not touch that one. Out of zeros and positives only, we have to choose the most minimum value. Out of 1.3 and 3 and 3, which one is the most minimum? Minimum ratio, that's the most minimum is 1.3. Put one arrow here. That means I choose the row S1 row. That means S1 row. If you come like this, S1 is the leaving variable. S1 is the leaving the basis. S1 is leaving the basis, whereas X2 is entering variable or X2 is entering the basis. So that what we have to do? First S1 is leaving variable. That's why we will leave S1 and S1 in place of S1 you will get X2, and above X2 how much is there? 4 is there. As it is, I'll write and 0 S2 0 S3 I will write as it is. The remaining 2 rows I will write as it is, and X2 is entering. That's why I entered X2, and above X2 4 is there I wrote. And if you come these two values like this you will get. If you come, the coincide value is equal to 3 is the coincide value. That 3, put one round off to the 3. 3 is called pivot element. 3 is called pivot element. What we have to do with the 3? We have to we have to convert the 3 into 1 and the below elements into zeros. Convert the 3 into 1. This 3 is called pivot element. Convert the 3 into 1 and below these two elements into zeros. Now how to convert the 3 into 1? Dividing the complete row with the 3, then only you will get here 1. Now dividing the complete row with the 3 means 1 by 3 is 1 by 3, 3 by 3 is 1, 0 by 3 is 0, 1 by 3 is 1 by 3, 0 by 3 is 0, 0 by 3 is 0, 4 by 3. Now we have to convert these two elements into zeros. To convert these two elements into zeros, we have to perform some elementary row operations. To do the elementary row operations, whatever the element we are going to convert into 0, first write down that row. That row is called old row, OLD, old row. Old row is this element I am going to convert into 0. This is old row. That row I am writing 2, 1, 0, 0, 1, 0, 3. Now, after converting the pivot element into 1, whatever the value you have got, whatever the row you have got, that is new row. New row is 1 by 3, 1, 0, 1 by 3, 0, 0, 4 by 3. Put one arrow, and in which place we have to get 0? Here in the second place. Now the old row, whatever the element we are going to convert into 0 is the old row. After converting the pivot element into 1, whatever the row you have got, that row is a new row. Now put one arrow. We have to get in the second place 0. Second place 0. To get 0 here, I have to subtract or add. Whether shall I add or subtract? I have to subtract. While subtracting, we need to change the signs. 1 minus 1 is 0. 2 minus 1 by 3. 2 minus 1 by 3. LCM is 3. 3 2s are 6 minus 1. 5 by 3. 0 minus 1 by 3. 1 0. 3 minus 4 by 3. LCM is 3 minus 4 by 3. 3 3s are 9 minus 4. 9 minus 4 is 5 by 3. Here 5 by 3, 0, 0, minus 1 by 3, 1, 0, 5 by 3. Next, which element we have to convert into 0? This element. How to convert this element into 0? To convert this element into 0, first write down that row, complete row, old row. Old row is 0, 1, 4, 0, 0, 1, 3. And the new row means whatever the pivot element, if you convert into 3, convert into 1 is the new row. That one I will write first. New row. 1 by 3, 1, 0, 1 by 3, 0, 0, 4 by 3. In which place I have to get 0? I have to get 0 here in this place. Second place is 0. To get 0, shall I add or subtract? I have to subtract. While subtracting, we need to change the signs. Plus 1, minus 1 get cancelled, 0. 0 minus 1 by 3 is minus 1 by 3. 4 minus 0 is 4. 0 minus 1 by 3 is minus 1 by 3. 0 minus 0 is 0. 1 minus 0 is 1. 3 minus 4 by 3. 3 minus 4 by 3. LCM is 3. 3 3s are 9 minus 4 is equal to 5 by 3. 9 minus 4 is 5 by 3. So that you will get the third row as minus 1 by 3, 0, 4, minus 1 by 3, 0, 1, 5 by 3. So that you will get like this. Now we will find the index row elements. How to find the index row? Again, how to find the index row? using the formula Zj minus Cj. Using the formula Zj minus Cj. Zj minus Cj means Cb column into first column minus Cj element minus this element minus 2 we have to do. 4 into 1 by 3 plus 0 into 5 by 3 plus 0 into minus 1 by 3 minus 2. That means how much you'll get? 4 into 1 by 3 is 4 by 3 minus 2. 4 by 3 minus 2 is LCM if you find 3. 4 minus 6. 4 minus 6 is minus 2 by 3. Here minus 2 by 3 you'll get here. 4 into 1 is 4 plus 0 minus 4 0. 4 into 0 0. 0 into 0 is 0. 0 into 4 is 0 minus 1 minus 1. Here 4 into 1 by 3 plus 0 into anything is 0 plus 0 into anything is 0 minus 0. 4 into 1 by 3 is 4 by 3. Here 4 into 0 is 0. 0 into 1 is 0. 0 into 1 is 0 into 0 is 0 minus 0. 0. 4 into 0 is 0 plus 0 into 0 is 0 plus 0 into 1 is 0 minus 0. 0. Now here 4 into 4 by 3. 4 4s are 16 by 3 plus 0 into 5 by 3 is 0. 0 plus 0 into 5 by 3 is 0. 4 4s are 16 by 3 here. Now if you observe this values index row elements, the most minimum is, what is the most minimum? Here how much you'll get? 0.24 20 0.6 minus 0.6 minus 2 by 3 means minus 0.6 and this is minus 1. Which one is the most minimum? This is the most minimum one. Minus 2 by 3 minus 1. Out of these two, most minimum or most negative is minus 1. That means I choose the column x3 column I choose. Now coming to the minimum ratio. 4 by 3 by 0. I choose this column. 4 by 3 by 0 is infinity. 5 by 3 by 0 is infinity. 5 by 3 by 4. 5 by 3 by 4. How much you will get? Whatever the value, some positive value will get. Now this infinity, 2 infinities we will ignore. This is the only value we have to take. 5 by 3 by 4. If you simplify, you will get some value, some number, some positive value. That only occurs. That's why we will choose that row completely. That means we choose this third row. Means S3 is S3 is leaving variable, whereas x3 is entering variable. S3 is leaving the basis, whereas x3 is entering the basis. Now the first two rows I will write as it is 4 x2 and 0 s2 I will write as it is, and what I will write, x3 is entering the basis. X3 entering, above x3 how much is there? 1 is there. X3 is entering the basis. And I'll draw the lines like this. Now I completed these columns, and then S3 is leaving the basis, whereas X3 is entered the basis. X3 entered the basis. Now what we have to do, the coincide value we will identify. If you come this side like this, you will get this is the pivot element. 4 is the coincide value is the pivot element. What we have to do with that pivot element? We have to convert the pivot element into 1 and the above elements into zeros. Already the above two elements are in the form of zeros only. That's why first we will convert the pivot element into 1. Pivot element into 1, that means if you divide the complete row with 4, you will get 1 there. Now here minus 1 by 3 by 4 is equal to minus 1 by 3 into 1 by 4 minus 1 by 12. I'll write minus 1 by 12. 0 by 4 is 0. 4 by 4 is 1. Minus 1 by 3 by 4 is again minus 1 by 12. 0 by 4 is 0. 1 by 4 is 1 by 4. Here 5 by 3 by 4. 5 by 3 by 4. 5 by 3 into 1 by 4. 5 by 12. 5 by 12. These two elements I will write as it is. Why? Because already zeros occurs. 1 by 3. 5 by 3. 1, 0, 0, 0. 1 by 3 minus 1 by 3. 0, 1, 0, 0. 4 by 3, 5 by 3. Now we will calculate the index row elements. If you get the index row elements are all greater than or equal to 0, then we reached the optimal condition. If we did not reach the optimal condition, if is there any negative occur, we have to move further again, we have to go to the next iteration. We will multiply. Simplifications, fractions are there, do the simplifications carefully. 4 into 1 by 3 means 4 by 3 plus 0 into 5 by 3 is 0. 1 into minus 1 by 12 is minus 1 by 12 minus 2. How much you'll get? LCM is 12. 3 4s are 12. 4 4s are 16 minus 1 minus 24. Now if you simplify 4 into 1 by 3 plus 0 into 5 by 3 plus 1 into minus 1 by 12, if you simplify, you will get minus 25 plus 16 by 12 is minus 9 by 12. 4 into 1 plus 0 into 0 plus 1 into 0 minus 4, 0. 4 into 0, 0 into 0, 1 into 1 minus 1, 0. 4 into 1 by 3 plus a 0 minus 1 by 12. 4 into 1 by 3, 4 by 3 minus 1 by 12. How much will get? 12. 16 minus 1. 16 minus 1 is 15 by 12. 15 by 12. This into this plus this into this plus 1 into minus 1 by 12 minus 0. You will get like this. Now 4 into 0, 0. 0 into 1 is a 0. 1 into 0, 0 minus 0. 0, 0. 1 into 1 by 4 is 1 by 4. Minus 0. Now 4 into 4 by 3, 16 by 3 plus 0 plus 5 by 12. 16 by 3 plus 5 by 12. 16 by 3 plus 5 by 12. LCM is 12. LCM is 12 now. Now if you simplify, 4 into 4 by 3 plus a 0 plus 5 by 12. 69 by 12 you will get here. Now did we reach the optimal condition? Check it out. We did not reach the optimal condition. We have to go for the next iteration. How to do the next iteration? The most minimum value, the most negative in the index row. This is the index row. The most negative is this one. Now Zj minus Cj. We choose the first column, we choose the first column. That means x1 is entering, whereas minimum ratio we will find. Minimum ratio 4 by 3 by this constant by the first column elements. 4 by 3 by 1 by 3. 3 cancel. 4. 5 by 3 by 5 by 3 is equal. 5 by 3 by 5 by 3 is equal to 1. 5 by 12 by minus 1 by 12. That is equal to 12. 12 cancel. Minus 5. Negative. Just ignore the negative. Out of 1 and 4. Out of, is there any in the minimum ratio any negatives or infinity? If you get, you have to just omit or ignore. Out of positive and 0 values only, we have to choose the most minimum. 1 out of 1 and 4, the most minimum is this is equal to negative. Just ignore 1 and 4. The most minimum is this one. Just that's why I choose this row, S2 row. Choosing the S2 row. S2 is leaving variable, whereas X1 is entering variable. X1 is entering variable means the coincide value is 5 by 3. What we have to do with that 5 by 3? First we'll the 4 x2 as it is, right? S2 is leaving variable, whereas x1 is entering variable, and x1 I will write above x1 how much is there? 2 is there. Now x3 and 1 as it is, I'll write. Now what we have to do? We have to convert the pivot element into 1 and the above element and below element into zeros. Pivot element into 1. How to convert the pivot element into 1? Dividing the complete row with the 5 by 3. Now first I'll convert the pivot element into 1. 5 by 3 by 5 by 3 is 1. 0 by 5 by 3 is 0. 0 by 5 by 3 is 0. Minus 1 by 3 by 5 by 3. 3 cancel. Minus 1 by 3 by 5 by 3. 3 cancel. Minus 1 by 5. Minus 1 by 5. 1 by 5 by 3 becomes 3 by 5. 0 by 5 by 3 becomes 0 by 5 by 3 becomes 0. 5 by 3 by 5 by 3 is 1. Like that I converted the pivot element into 1. This element and this element we have to convert into zeros by doing some elementary row operations. Now whatever the element we have to convert into 0, that one is called old row. I told you that one we will write first. Whatever the element we are going to convert into 0. 1 by 3, 1, 0, 1 by 3, 0, 0, 4 by 3. Now after converting the pivot element into 1, whatever the value is there, that one new row. 1, 0, 0, 1 by 5, 3 by 5, 0, 1. Now I have to get 0 here in the first place. This is the old row, this is the new row. Old row means whatever the element we have to going to convert into 0 is the old row. After converting the pivot element into 1, whatever the row we have got, that is the new row. Now here to get 0, what we have to multiply the new row with? 1 by 3. Now I'll write 1 by 3, 1, 0, 1 by 3, 0, 0, 4 by 3. 1 by 3 into the new row. 1 by 3 into 1 is 1 by 3, 0, 0, minus 1 by 15, 3 cancel, 1 by 5, 0, 1 by 3 into 1 is 1 by 3. Subtracting. 1 by 3 minus 1 by 3, 0. 1 minus 0, 1. 0 minus 0, 0. Now LCM is 15 is LCM. 1 by 3 plus 1 by 15. 3 ones are 3 5s are minus 1 plus 1. 15 cancel, plus 1. 5 plus 1, 6 by 15. 6 by 15 is 2 by 5. 2 by 5. Here minus 1 by 5. 0. LCM is 3. 4 minus 1 is equal to 3 by 3 is equal to 1. Like this I did the simplifications. Now I'll write how much you have got? 0, 1, 0, 2 by 5, minus 1 by 5, 0, 1. Now next this element we have to convert into 0. 12. Whatever the element we are going to convert into 0, that one we should write first. Old row, minus 1 by 12, 0, 1, minus 1 by 12, 0, 1 by 4, 5 by 12. Next, after converting the pivot element into 1, whatever the value you have got, that one means 5 by 3, 1. 1, 0, 0, minus 1 by 5, 3 by 5, 0, 1. Now I have to get this element into 0. To get this element here 0, I have to multiply the new row. This is new, this is old. I have to multiply this new row with 1 by 12. 1 by 12. 1 by 12 means how much you'll get? Now again I'll write minus 1 by 12, 0, 1, minus 1 by 12, 0, 1 by 4, 5 by 12. 1 by 12 into 1 is 1 by 12, 0, 0, minus 1 by 5 into 12, 60. Next 3 into 15 5s are 60, 0, 1 by 12. Now here to get 0, shall I add or subtract? We have to add. Minus 1 by 12 plus 1 by 12, 0. We have to add 0 plus 0, 0, 1 plus 0, 1. Now here LCM is 60. 12 5s are minus 5. Minus 1. Minus 1 is minus 6 by 60 is equal to minus 1 by 10. 3 by 60 is nothing but 1 by 20. 1 by 4. Here 12 is LCM. 5 plus 1 is 6 by 12. 6 by 12 is 1 by 2. 0, 0, 1, minus 1 by 10, 1 by 20, 1 by 4, 1 by 2. Now we will calculate the index row element. Now after finding the index row, we can check whether we can move further or we can stop the iteration. Did we reach optimality or not, we will see. 4 into 0 plus 2 into 1 plus 1 into 0 minus 2, 0. 4 into 1 plus 0 plus 0 minus 4, 0. 4 into 0, 0 plus 0 plus 1 minus 1, 0. Now here the simplifications we have to do. 4 into 2 by 5. Simplifications, do it carefully. 4 into 2 by 5 minus 2 into 1 by 5 minus 1 by 10 minus 0. LCM is 10. 5 2s are 10. 2 2s are 4. 4 4s are 16 minus 16 minus 5. 16 minus 5 is 16 minus 5 is 11 by 10. 11 by 10. Here next simplification. Minus 4 by 5 plus 6 by 5 plus 1 by 20. 20 minus 16 plus 1. 25 minus 16. 25 minus 16 is 9 by 20. 25 minus 16, 9. 9 by 20. Now here 4 into 0, 2 into 0, 1 by 4 minus 0, 1 by 4. Now we will calculate 4 into 1, 4 into 1, 4, plus 2 into 1, 2, plus 1 into 1 by 2. How much we will get? 4 plus 2 is 6. 6 plus 1 by 2. 6 plus 1 by 2. 13 by 2. 13 by 2. Now all index row elements are greater than or equal to 0. Therefore, we reached optimal condition. We reached the optimal condition. Therefore, the maximum, the value, therefore in the next line I will write, therefore max z is equal to, now whatever the right side corner, whatever you have got, whatever in the next index row elements greater than or equal to 0, we reached the optimal condition. Therefore max z is equal to, in the right side corner whatever the value we have got, that one is 13 by 2 at x1 is equal to 1, x2 is equal to 1, at x1 is equal to 1, x2 is equal to 1, x3 is equal to 1 by 2. If you substitute all these x1, x2, x3, x1, x2, x3 in the objective function, again you will get 13 by 2. 13 by 2 you will get. This is simplex. Thank you.